So we already got one question from to the Wilson. So there are two questions. First one is how much the reflection be affected if we have high porous regress or least regress? And the second one is, can you comment on the capability of LiDAR to screw the inside PSR before the rover will enter the PSR?
Yeah, so I think that if the a porous regolith would have just all the other things being equal would have less reflectivity than something that was more massive, just because you'd have less scattering in the massive example, and we've seen that from basalt and volcanic deposits where the vesicles, if they're smaller than the spot size, they still scatter plenty of stuff and they lower the reflectivity. And LiDAR would have no trouble at all scanning inside a PSR before the rover got there. That would be exactly a why that would be a project number one. Why I think it would be a good science instrument to put on the PR.
Okay, and the next third question has come. So question to Dr. Ori. Have there been instances where the guidance navigation LiDAR have been leveraged for science?
Um, So we have not yet sent a lidar to the surface of a planet. Guidance lidars for landing in the cliffs maybe recently that I'm not sure about, but we have yet to have this scenario where an engineering lidar has been on the surface that we could leverage it for science. We have done that regularly with rovers on Mars with the cameras. So navigation cameras have been really good science tools, even though their principal mission is to keep the rover safe.
Mm. All right, thank you. Question to the Tsuji-san. So how do the small active source devices stay coupled to the surface?
Yeah. So can you hear my voice now? Okay.
Yeah.
Okay. Thank you. So yes, in the case of the moon, we need to couple because so it's one of the difficult things. But now we try to develop the automated array system from Rover. So it's smoothly the deploy our seismic source to the moon surface. Yes, but a coupling is necessary. Yes, you are right.
Right. And question to the Henderson-san. Do any of the Mars rovers have the capability to take images in the absence of sunlight?
Yeah, the Molly Hanlon's camera, it actually has its own LEDs and actually some UV lights. And so we are able to take images at nighttime with those. And that's really interesting because it's your best way to understand color is to have a consistent light source so you can actually see color differences in that reflection. On the moon, like for Artemis, what we're planning to do is to take images at multiple exposures. And so that could be a really good way to consistently collect images that do take into account some of the extreme lighting environments that are there.
And maybe for to the question to the listen. So, what's the expected cost for building a base near Caribbean versus base in the poor region?
I guess that's for me.
Yeah, sure.
The cost of establishing an initial small base would probably be very similar between Clavius and the South Pole, but the cost of operating the base and eventually growing it would be, I think, significantly cheaper, just because of the fact that the operation's a lot simpler and the thermal environment a lot more predictable and easy to manage at Clavius. I mean, at Clavius, you'd have to survive the lunar night, and therefore you'd have to go nuclear up front, pretty much. Whereas at the South Pole, there are claims that one would use, solar power from the semi-permanently illuminated areas, but I think that's not very realistic either because of the dust issue from Starship landings and taking off. Having a solar farm in sunlit areas at the South Pole is not going to last very long. Plus, you can't really power a base if it grows eventually substantially with ground-based solar power. I mean, Perseverance and Opportunity are already using RTGs, not solar panels, just for the small vehicles that they are. You can imagine that solar will be unwieldy for actually a base operation, really.
And then the next question to the Lee-san. So I love the idea of the near side base, such as previous. But if the peer can only survive 192 hours of darkness, doesn't the imply chasing the sun at the near polar location? How could the peer work at the 61 degrees south, where there would be a full 2 weeks of darkness?
Yeah, well, you will need some RTG source to plug into to stay warm through the winter, not through the 2 weeks of darkness. You need nuclear to survive the lunar night. So it's I'm not suggesting that this is a scenario that we're ready to switch to easily. I'm just saying that this is really a desirable evolution of what we're trying to do, because I think the repeated sortie missions, one Artemis landing at a time at the South Pole, is very satisfying, in the initial stage, because it's sort of the science buffet approach to sampling. But it doesn't really result in an infrastructure that's easy, that's going to allow you to return to the moon and grow. And the other thing, of course, is that, again, none of the areas in the lunar polar regions are good as an exploration base, because of this whole chasing the sunlight issue and escaping the shadows. So you really want to have a base that's in a much more benign and predictable environment, thermally and illumination wise.
There's a question there are two questions to Willie-san. So first one is what type of rider would you think is best for the moon, where there are no satellites for georeferencing purposes?
Yeah, it's interesting.
Second, go ahead. Sorry, go ahead, please. Yeah.
I think it's an interesting point. I think if you know where the rover is, you can figure out the rest of it. So that would be the counterpoint. Any lidar would have the same georeferencing issues, but I do think that there's a lot of promise in terrain recognition software that's being developed, that you could, if given a good enough orbital product, you could use the terrain that the lidar measures from the rover to find out its own position, and you could do that with a lidar that had a reasonably long distance mode, or reasonably tight angle, so that it could see pretty far. I think the other piece that to worry about for a lidar architecture on the moon is moving parts. I think that a rotating stage instrument would be a candidate for getting dust crammed in the mechanisms, and that would be bad news. So something with less moving parts, like a MEMS or something like that, flash lidar, but one that had a really tight angle would be my suggestion. And then the next question is about dust. Will dust scatter the lidar, and could that be used for science? Absolutely. There are lidars that are purpose built for looking at atmospheric anomalies on Earth, and you wouldn't need something like that, really. You could just use a lidar in a mode that was looking for detections at a shorter amount of time, or something that was closer by, if you knew where the dust was going to be, or you had a prediction of where the dust might be, and you could pick up those detections. We find in doing terrestrial field work that we get, we usually try and filter that out, but if it's a particularly windy day, we'll get dust clouds that make some fuzz in the point cloud. And if we're trying to look at rocks, we might scan it again and ignore those data. But if you're interested in the dust, you could totally use those data for science.
Thank you for your answer. Another questions? License. I just make a memo, so please control this session, please.
We have plenty of time left in this this session before we move into general questions. So if anybody has other questions, please drop them in the chat.
So I actually have a question. Is it planned for the pressurized rover in uncrewed mode to be used as to be driven by astronauts on Earth who might be training or just staying trained in rover ops?
I think we're still in the early phase here, design phase. So I think a lot of the operational things will come to bear.
Yeah. But that might be something to think about in terms of creating a vehicle that essentially can be used as a simulator remotely.
Yeah, I like the idea for sure. Right. Well, any general discussion then around any of the topics we've covered over the last couple nights and mornings? I think a couple thoughts that I've had is is thinking about the significance of payload location and where people can get the best science, and how that plays into the rover. So I'm excited that there is different accommodations for different positions for different instruments, and it's certainly something to be considered. See a question about the data uplink budget for the rover. Yeah, it's one of those larger architectural questions that will unfold as things progress.
Do you anticipate follow-up pressurized rover workshops like this one? Because I thought this was really interesting and good.
Yeah, thanks for that comment. We sure do. Yeah, I think what we can probably expect over the next several years is to host one of these. Of course, if with JAXA and if they're agreeable to it. So I think that's a good option, and we'll I think different stages of the build as it heads towards launch. Yeah. Tomi-san, any comments or thoughts to share?
Just a moment. Yeah. So also the question is finished. So could you remind us what the timeline to review and down select various science proposal? It's a good question. Maybe question to JAXA and NASA. But we are actually not, we cannot answer this question at this point. But NASA and JAXA will hardly discuss about these concerns. Thank you very much for your questions. So, Ryan-san, so let's move to the final sessions. How do you think about it?
Yeah, Yeah, let's do. We've kind of started some general comments about payloads, future meetings, but
Yeah.
welcome other thoughts around.
So I just make a small note to summarize the 2 days presentations. May I just no PowerPoint file, but also just I want to talk about the summary of the subjects, right?
Great. Yeah, thank
Okay.
you.
So yesterday we had the 3 sessions. First one is pressurized rover overview from JAXA and NASA. Second one is the payloads instrument, imaging and spectroscopy. And third one is payloads and instruments, volatiles. And the first session, pressurized rover, in the pressurized rover overview from JAXA and NASA, there are many technical questions, including the charging capacity of the PR, temperature control of the payloads, sensor to be installed, possibility to invite in scientific equipment from other countries, and operational concept. And in the payload on the instrument imaging and spectroscopy, so compact multispectral imager for geological survey for the lunar surface and quantum gamma ray imaging spectroscopy for lunar resource exploration are reported. And in the payloads instruments volatiles, so non-contact water resource exploration using the neutron detection of the substance hydrogen using the active neutron spectroscopy and tinsel, which enable remote multispectral imaging are reported. And there were questions about the detail for the method for measuring the water using the neutrons preparation for simulant, possibility of the tensor using tensor during the landing or cargo landers or HLS on the moon. And the second, next day, today. So first session, there are 3 sessions, and JAXA's lunar scientific objectives and payloads and instruments, geochemistry and exploration strategies. In the JAXA's lunar science objectives, lunar decameter wave telescope, Japanese lunar seismic network, and insight analysis and sample return are reported. And there are questions about the placement of radio telescope and lunar seismometers, and the advantage of the proposed sample return plan and size of samples to be collected by the coring drills, and operational safety on the equipment are this equipments. And the payload and instrument geochemistry may plan ribs for mapping the distribution of minerals in rocks outcrops. And there are questions mainly about the performance, such as the degree of freedom maple and the sensitivity of the ribs. And the last session in the exploration strategies, preparation for creation of lunar samples, installation of scientific cameras, installation of PR-mounted radars, implementation of surface wave analysis, and PR travels between the lunar south pole and the previous crater are reported. And there are questions about the capability of radar, the installation of small active sound source devices, and possibility of crossing the previous craters, and the ability of the take image in the absence of sunlight. All right. Maybe I forgot the something about this. Sorry, but a lot of questions there are. So this is just my memory memo. So please go ahead. Pre-discussion about the scientific things and technical things for the PR.
Thank you so much, Tomi-san. Yeah, that was a nice summary of what we heard, and I think we've covered a lot of ground over the last few days. I was reminded one area who I don't think we had any presentations on, but would be the internal rover science, IVA science, and we have somebody from we have Matt Lira from Biological and Physical Sciences who's offered to say a few words about IVA science that and payloads. I think if Matt's still on and would be willing to say a few words about IVA science. I guess Ricky, if you could unmute Matt, if he's still around.
Stand by.
Oh, we might have lost him. Maybe he had to sign off.
Yeah, I don't see him on the list anymore.
Okay. Yeah, we were trying to find time for him throughout here, but we had so many good questions. But yeah, it's just to say that the pressurized rover will have internal payloads, and there's opportunity that those could be used for uncrewed science, for the duration of the uncrewed period, potentially swappable, by crew at different points. And I think we have experience from ISS and of a lot of good science, great science that's come from both biological and the physical side. I think biological, you run into questions of how to keep your specimens cold, etc. But certainly physical experiments in 16G could benefit from being inside the rover for longer duration. So we'll look forward to what those payloads end up being as well. Well, yeah, we welcome any more questions. And if we don't have any, we'll probably end a little early. What do you think, Inatomi-san?
I have a question to the presentators. Okay.
Sure. Yeah.
Yes, it's simple question. That's a kind of suggestion. So all the presentators, assuming using the Pressurized rover, is there any possibility of cooperation between the science you are aiming for and the expected results? So if we have some suggestion, please talk about it, if possible.
And just raise your hand if you want to respond to that.
So Inatomi, just to read back, that's talking about you said collaborations, or I guess could you repeat the question, please?
Yeah. Okay. Is there any possibility of cooperation between science you are aiming for and expected results? Please also consider the perspective of international cooperation. That's my questions.
Yeah, thank you. Yeah, so opportunities for international cooperation, collaboration, and results. Yeah. So it looks like Patrick has his.
Okay, Wilson, so please. Ricky-san, Wilson can speak or not?
Yeah, so I think it's an excellent point and a good question. And I think so my presentation about LiDAR, I didn't have an instrument that I'm particularly proposing. I'm more interested in I could work on an instrument that for sure, but I'm more interested in boosting the technique, and I would be very happy to talk to make collaborations about for international collaborations with JAXA folks about ideas that they had for applications for LiDAR or other ideas for this trade space, because I think that part of the word I wanted to get across was that there's a lot of different ways to use the instrument and a lot of different ways that you could put places you could put it on the rover. And I think getting into the details of what's the most important and what's the best way to use one of these instruments is something that I certainly would need some collaboration to be able to comment on. So absolutely, yes, please, for collaboration.
Good suggestion. Thank you.
Yeah, thank you.
Nothing from Japanese side?
Like a question about the next step for this forum. So yeah, I think thinking about another lunar surface science workshop dedicated to pressurized rover is something we've discussed, and I think it would probably be a little down the road as we kind of understand more about where things are headed and in the design and where we want to go.
Good question.
Yeah, thank you for the question.
Okay, so my question is want to be closed. So, okay, thank you very much. Willie-san. 長岡さん is raise hand. Okay, raise hand. So, please, 長岡さん, can you speak?
Being unmuted, I think.
長岡さん, you are muting.
Maybe Ricky.
Ricky-san, please.
Okay, yes.
Mic is still muting. Okay.
Okay, thank you very much. I reply to for the Minatomi-san's comment. So our mission plan to return sample is requires the approaching the large boulders by the pressurized rover. It is dangerous to approach the near the large boulder. So today's talks provide the LiDAR development. So LiDAR is very useful to approach the navigation to make measure the distance for the boulder. So it is very useful. So we want to cooperation to discussion sample return mission with using the LiDAR. This is just idea. So thank you very much.
Thank you very much for your comment, Nagaoka-san.
Thank you very much.
Yeah, thank you for that comment. I think I had made a note of that as well, of a lot of payloads want to be near the target. Certainly something that requires the LiDAR and camera systems to allow that. So yeah, good to see the diversity of payloads and the requirements for those payloads to do the science they intend to do.
Ryan-san, so if there are any additional questions, so please move to the wrap up. I mean, it's a closing remarks. How do you think about it?
Sure. Yeah, let's do it. Let's wrap up.